Okay, we are still on section 3.5, overlapping triangles. This is number 10, and I have my diagram right here. Notice how I need to prove AC, which is now this big segment, is congruent to AD. Do you see the two overlapping triangles on the bottom? I'm going to highlight it this time for you. So I have triangle BCD, and notice how I separated it here for you. And then I also have triangle EDC. Now, if I prove those two triangles congruent, I will be on my way to proving this final statement, AC is congruent to AD. So let's check out what we're given here. It says it is given that B is the midpoint of AC. Well, we know if B is the midpoint of AC, that it cuts the segment AC in two congruent parts. So I'm going to go ahead and place tick marks there. Also, E is the midpoint of the segment AD. So I'm going to put tick marks here. Now I'm going to change the type of tick mark because I don't know that AB is congruent to AE. All I know is that AB is congruent to BC and AE is congruent to ED. And that's because we have these statements in the given. So that's what I'm going to write next. AB is congruent to CB and AE is congruent to DE. And we can say, since a midpoint cuts a segment into two congruent parts. Okay, now I'm also given angle 7 is congruent to angle 8. So those are these two outside angles. Also, ECD, that's this angle here, is congruent to angle BDC. So I'm going to put those tick marks on my separated angles here. So we have ECD and BDC. Okay. So again, I want to prove these two triangles congruent. Now notice they share a side here, CD. I have CD here and CD here, so we know that CD is congruent to itself, right? And we are going to use axiom 8. Remember, axiom 8 says magnitudes which can be made to coincide with one another are equal. Or you can think of it as the reflexive property. So CD is congruent to itself. Okay. Now, it would be nice if I got this angle, BCD, congruent to angle EDC, because if I did, then these two triangles would be congruent by angle side angle. Okay, but we don't have that yet. But notice that in the given, I have angles 7 and 8 congruent. So I'm going to do something with that. Now, I could say that angle 7 is supplementary to this angle that I am outlining here for you, because we can assume that straight angles, sorry. So let's write that. Angle 7. Now what angle is that? So angle 7 is supplementary to angle BCD. Okay, now angle 8 is supplementary to angle EDC. Oh, and I realized I forgot to do this on my last proof. Make sure you justify this. I didn't in my last proof. Forgive me for that. But you have to say assuming straight angles. Okay, there always needs to be a justification for the things that we say in a proof. Okay, now, again, remember in our given, angle 7 and 8 are congruent. So I'm going to circle those here. And then we can say that angle BCD is sup to the same angle that EDC is sup to. So that makes these guys congruent by the congruent supplementary theorem. So let's say that next. Okay, now I'm going to draw in the tick marks for angle BCD, which is right here, and EDC here. And I won't even bother putting the tick marks up above in that because I can see now clearly these two triangles, the one that I highlighted in pink and in yellow, are in fact congruent by angle, side, angle. So let's write that next. Actually, let me save some space. I'll write it right here. Okay, well now if the triangles are congruent, then I know parts of the triangle are congruent. So I'm going to say that this part BC is congruent to ED. Remember, that's by CPCTC. Okay, so remember now in the very beginning about the midpoint. Now we're coming back to that, the given portion about the midpoint. Remember that BC is congruent to AB. So what I'm going to do is now like double BC, right? Because BC and AB are the same. So those are equals, and now I have two of them, which make the whole segment AC, which is part of the thing I want to prove. So I'm going to be using axiom 6. It says things which are doubled of the same thing or of equal things are equal to one another. So we know that BC and AB, those are doubles of the same thing, right? And same thing here with ED and AE. And since I already proved that BC and ED are congruent, I can now say that the whole thing, AC, is congruent to AD using axiom 6. So that's what I'll say in my last statement. Okay, and that concludes the proof.